Hello friends, we are going to do 6-4. I actually thought I put this video on there, but the link wasn't working, so I'm going to redo it and post it. Sorry, it's a little bit late for some of you. We're going to be talking about inverse functions. With an inverse function, what I always think is that it undoes. It's going to it undoes the original functions. You're kind of going backwards. So if you look at a function as like I'm putting in an x, this is happening to it, and then it's going to kick out my y, which is technically written like this. So the function in here is going to do whatever that math rule is. That says rule, even though you can't tell. So let's say you add 2. Well, if you want to undo that, you would have to take away 2. If you're going to divide by 3 going forward, you would have to multiply by 3 to go backwards. So inverses are like math opposites of each other. And so this is going to be math opposites. I'm sure there's much more fancy terms. And they kind of undo each other. So squares and square roots, adding to subtracting, and so on. And then when you're going backwards, what ends up happening is like you're saying, I'm going to go back this way. So the x's and y's kind of swap spots. So the x was the input. Now the y is kind of coming back through from the other direction. So the notation, we always use this notation as the original function. And then we use f to the -1 as the inverse function. So you're saying I'm going to undo that previous function. So when you're given an equation, how do you find it? It's a 2, kind of maybe 3-step process. Because of what I was saying earlier about going in as an x, coming out as a y, and then you're going backwards, you swap your x and y in the equation. So you literally put the y where the x was and the x where the y was. Then you're going to move stuff around using math opposites to solve for y, which is something we talked about at the beginning of the year. Solve for y really just means get the equation as y equals something. And then the third step, if you want to call it a step, is instead of y, you would write it technically as f inverse x, saying, hey, I just found the inverse of the original function. So if this is my original function, this is just kind of a fancy way of writing y. So I'm going to write it as y equals 3x minus 2. Then I'm going to do step 1, which is to swap the x and the y. So this goes here and this goes here. So swap and solve. Swap and solve. That's all you're doing. Now I need to get this y alone, and so I'm going to do that by using algebra 1. I'm going to move the 2 over. I'll have x plus 2 equals 3 times y. Dividing out the 3, I'm done. And so, like I was saying, the third thing would just be to write it in this inverse notation and say, hey, y, or f inverse, is x plus 2 over 3. One thing you can kind of do to scope it out at the beginning is to say, like, look here and think about what you would expect as opposites. So since there's a -2, I kind of expect a +2 somewhere in my problem. Since this is 3 times x, I kind of I expect to divide by 3. And so then when you look down here and you see both the adding of 2 and dividing by 3, kind of makes you feel like, well, I got what I expect to get, because those are the math opposites. So let's take a look at 2 more examples, then we'll talk about the other thing for today. I'm going to write this as y equals 2x cubed plus 1. Then I'm going to swap and solve. So this is going to become x, and this is going to become 2y cubed. Now I'm trying to get this y alone. So I use algebra 1. I take away the 1. Algebra 1 to take away a 1. Then I have 2y cubed. So the 2 is multiplied in, so the math opposite is dividing. So now I have y cubed equals x minus 1 over 2. But from what we're learning right now, you could cube root that, but then you have to do that to the other side. The cube and the root cancel, and then I would rewrite this and say, hey, my inverse is cube root of x minus 1 divided by 2. So this is my finished product for the inverse. So let's look back here again. What did we have here? We had 3 as a power, so the opposite of that is cube root. We have a plus 1, so we would expect So we had a +1, so we're going to expect a -1. And then we have a times 2, so we would expect a divide by 2. So when I see that, I've got my -1, I've got divided by 2, I've got a third root. Those are all the things I would have expected to see. Here, I have a fifth root. So if the fifth root is what you have, you expect to see a fifth power because they're opposites. I have a -3, I expect to see a +3. I have a divided by 2, I'll expect to see a multiplied by 2. These are just things that I expect in my answer, but I write it as y. Then I'm going to swap, put my x here and my y here. Now to get rid of this fifth root, I use a fifth power. Roots and powers are math opposites or inverses. So this looks really terrifying, but the fifth power and the fifth root just cancel. So at that point, I'll have x to the fifth equals y minus 3 divided by 2. Time to get rid of the divided by 2, so I multiply it to both sides. Here it cancels. So I have 2x to the fifth equals y minus 3. So then my only extra step is to add 3. And then instead of writing it as y, I'm going to write it as that kind of fancy f of x notation and say, hey, the inverse is what I got over here. So 2x to the fifth plus 3. And I have the elements I expect. I had a multiplied by 2, I have a plus 3, and I have a fifth power. All right, so the other element that we need to do is learn how do I tell if the function has an inverse based on the graph. So we've done something similar to determine if the graph, meaning f of x, meaning the original, is a function. We use something called the vertical line test. This was way at the beginning of the school year, so let's revisit that, plus it'll be on our semester final. So the vertical line test, you use it on the graph to see if the function is an inverse, meaning I can look and imagine as many vertical lines as possible, and each one only hits the graph in one spot, telling me that each x has only one y. So then this question is asking me, is the original a function? And the answer would be yes, it is a function because it passes the vertical line test. How about this next really fuzzy graph? If I draw vertical lines in, they all cross this graph one spot only, and so therefore it passes the vertical line test, and this is a yes. However, in the last fuzzy graph, the vertical line that I would draw, it crosses two places. And I actually have several that cross two places. I only need one spot where it does that. And I would have to say, no, this is not a function. And the reason this initial one is not a function is that it fails the vertical line test by crossing it twice. So that actually is not new. That's something we have done from a long time ago at the beginning of the school year. So what we're introducing today is, okay, now we're talking about inverses. So how do I do the same kind of thing to decide if the inverse is a function? Shockingly, I use the horizontal line test. Rule is the same. If it crosses more than once, then it fails. If it fails, then it is not a function. So now we're testing the inverses. And actually the notation on these is wrong. It should be a -1 power in each case. And so I'll just correct that. It's kind of a picky detail. If I look at this first graph and I do a horizontal line test, you can see that it crosses in more than one spot. So that means that it fails, and the inverse is not a function because it fails that horizontal line test. So the vertical line test tests the original graph, and the horizontal line test is done on the graph you have, but it tells you something about the inverse. So here, my inverse, I would use horizontal line testing, and since it hits here and here, it fails it. So that means my inverse is not a function. And so that is because it fails the horizontal line test. This was a yes because it passed the vertical line test. So for the original, we use the vertical line test. For the inverse, we use the horizontal line test, except for I can't write. So on this last one, if we did a horizontal line test, it would only ever cross this graph in one spot at a time. So it passes the horizontal line test. So even though this one failed the vertical line test and was not a function, the inverse actually is a function because it passes the horizontal line test. So if you remember, recall, understand the vertical line test, this is absolutely not different. This is going to be a really good review for the final two because this is asking you to graph something. Back in the day, we did absolute value graphs and they were V-shapes. They still are. We got the vertex from these two numbers. The vertex is this pointy part. But the vertex, you use the opposite of what's inside the absolute value bars, and then you use that number on the outside as is. So I'm going to go to -2, down 1, 2, 3, 4. And then this number, the easiest way to use that is to use it as the slope of the right side, knowing it's a V. So I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. Then to get the other side of the V, I go up 1, back 2, up 1, back 2. So that is my graph of f of x. But they are asking me to see if the inverse is a function, which is asking me to use the horizontal line test. And once I have this graphed, if I go to use the horizontal line test on it, it fails the horizontal line test. So the inverse of this would be not a function. So vertical and horizontal are always telling you if something's a function or not. The vertical line test would test the original and this one would pass that, but the inverse, it fails because of the horizontal line test. This was what we did in all of chapter 4. Quadratic is x squared. It's always a parabola. This is my a value. It's less than 1, so my parabola is going to be wide. It's positive, so it's going to open up. And if you went back to say, hey, a is a half, but my b is 0 and my c is 0, because I don't have the rest of the bx plus c part, then when you go to find the x coordinate of the vertex, you're going to be taking the opposite of b over 2 times a. So you end up with 0 over 1, which is 0. And then if you plugged a 0 in, a half of 0 squared is also a 0. So this goes here. If you want to plug in a couple of numbers, you certainly can. And you can say, all right, I'm going to plug in 1. Well, 1/2 times 1 squared is going to be a half. And then it'll match over here because remember we have that axis of symmetry. If I plugged in a -1, it would be the same thing because when I square the -1, it becomes positive. What if I use 2? 1/2 of 2 squared is 1/2 of 4. So I get a 2 here, and I would get the same thing if I plugged in a -2. So that gives me enough points to draw a pretty good graph of this. If I use the vertical line test on this, it would say, yeah, I did just graph a function, but it is asking about the inverse. And in this case, I would have to say the inverse is not a function again. And the reason the inverse is not a function is that it fails that horizontal line test. So the two key factors for today are using the horizontal line test to decide if the inverse is a function, and then using this old swap and solve to decide what is the equation for the inverse. So hopefully that helps. Bye.